Hello, everyone, for joining in. We're just going to get started in probably a minute or so, just letting everyone else join in. So give us a minute and we'll get started. Okay, so let's get started. Welcome everybody to today's webinar on the many flavors of DevSecOps Orchestration. So for those of you who are joining us for the first time for V45's webinar, we do a monthly webinar every month, usually in the last Thursday of the month or the penultimate Thursday of the month, depending on how the schedules are. And we talk about a bunch of topics ranging from appsec automation, cloud security, software security initiatives, and so on. So if you're joining us for the first time, welcome, and we look forward to seeing you in our subsequent webinars. So just a couple of matters of housekeeping before we get started. So if you do have questions for the presenter in the course of the webinar, we encourage you to use the Q&A tab at the bottom of your screens. If you could just post your questions in there, we'll take the questions at the end of the webinar, if that's okay with you all. You could use the chat window as well, in case if you're not hearing as well, or in case if you have any questions. But if it's any formal questions pertaining to the webinar by itself, we encourage you to use the Q&A tab, and we'll get to that to the end. Certain other announcements and for those who are kind of following V45, who've kind of been in the know of what we're doing, we do have 2 of our live remote workshops going that we're still running. One of them is the attacking and defending containers, Kubernetes, and serverless, that's starting June 22nd. I'm just going to put the links down here for all of you. So that's starting on June 22nd. And then we also have our DevSecOps Masterclass program that's starting on July the 1st. All of these are live remote programs, but you will have access to recordings, extended lab hours, even if you're not able to attend during the course of the program. So these are programs that have kind of featured in Black Hat, DEF CON, OWASP conferences across the world. So we're bringing it for the first time as a live remote program by V45 ourselves. So in case if anybody is interested, be sure to kind of take advantage of the sale that's going on right now in terms of the price. And we also encourage you to subscribe to our YouTube channel here. This is something that we keep updating every week in terms of our conference talks, in terms of webinars, the podcast that we do. So we're posting a lot of content on our YouTube channel the last couple of months, and you could take advantage of that as well. So with that, let's get started with today's webinar, the many flavors of DevSecOps Orchestration, which is going to be presented by Abhay. So with that, I will hand over the baton to Abhay. And like I said, if you have any questions, please do feel free to kind of post it on the tab. And take it away, Abhay.
All right. So hi, everyone. First of all, very happy to be here. And I hope that you are all staying safe and sheltering in place and making sure that you're safe, even if you have to go to work. So like Rahul said, we've been doing this webinar every month, and we also put out a lot of other content as well, especially on DevSecOps or anything related to the cutting edge of application security, typically cloud security, and so on and so forth. So with that, let's get started with this topic. This has been a topic that has been near and dear to me for a while now. Just give me a second. Looks like, am I not visible now? Still not visible. Okay. Okay, that's fine. So let's get started. My name is Abhay, and I'm the founder of V45. I'm involved in the technology operations at V45. So most of the products, the services, and around, of course, the solutions that we have, the technology landscape or the technology direction is typically shaped by myself. And I'm also the chief architect of Orchestron. Now, Orchestron, for those of you who have been following us, you probably know that Orchestron is our vulnerability correlation and management system, an application that we've built, and a lot of organizations use it as part of their application security program. But Orchestron is something that we internally came up with and then started to realize that there's a lot of there's a lot of scope for this for organizations to take advantage of this correlation technology. So my team and I have been instrumental in building out Orchestron and building out some of the new features of Orchestron as well. We have a host of new features on the way. So if you want to stay in touch, you can stay in touch on that as well. Of course, aside from that, I also do a lot of training. I'm one of the lead trainers at V45 at multiple events like DEF CON, Black Hat, and so on, at OWASP events as well. So I typically train on things like DevSecOps, Kubernetes, serverless, areas that are at the cutting edge of AppSec in general. So that's something that we specialize in. And that's typically what I do. I also write a lot of code. That's a lot of the research that you will see in all our courses are research that we as a team have collectively identified and come up with, either tools or something new in terms of methodology and techniques and so on and so forth. So this is something that you'll see. In fact, you'll see a lot of this in this talk as well. So that's going to be a few interesting things that you're going to see today. So like Rahul already said, we have two programs that are already running. The DevSecOps Masterclass on 1st and 2nd July, attacking and defending containers, Kubernetes, and serverless, 22nd to 25th July, that's next week. You don't want to miss these two. They're awesome programs, and they've been sold out most of our conference events that we've had them. And the cool thing is you also get access to certification, you also get access to labs, videos, and so on. So you should definitely take advantage of the real awesome price that we have at this time. In addition, of course, if you are attending any of these conferences over the next few months, you will catch us at these events. Black Hat, of course, we have two trainings happening at Black Hat, and we're really looking forward to those. Hack in the Box Singapore and Shack Singapore are something that we're very looking forward to as well. Of course, you'll catch us in most of the OWASP events, and of course, Echo Party in Argentina. We're really looking forward to all these events. Although all of them have gone virtual, we look forward to engaging with them in a virtual capacity. So I look forward to seeing all of you there if you are in any of these events. So of course, you can catch us on YouTube and of course the blog. I'm going to move on, right? So the agenda today is really to talk about something that's been on my mind for a while, right? Now, I've seen that there is a very large monoculture that's been kind of developed around DevSecOps. And my idea is that we want to talk about something a little different. Now, there are different ways of achieving the same thing, or there are different ways of achieving much better results. And that's something that I want to look at. We're always looking for different ways, newer ways, more innovative ways of solving problems. And that's something that I want to really get into when I want to talk about DevSecOps today. It's really not just going to be about, hey, you need to put this in your pipeline. I'm not going to be talking about that. I think most of you who are attending this talk kind of already know why DevSecOps is important. You probably want to know what are the different ways of doing it and why is this way or one way not the best way, right? So I want to talk about all these things. I want to showcase, of course, as always, a lot of demos. My talks usually have a lot of live demos, so you need to pray to the demo gods for me. So a lot of live demos as well. So I'm hoping to showcase all of this before the time runs out. So let's get started with our first problem. So the first thing I want to do is talk a little bit about the challenges. Then I'm going to talk about some unconventional approaches to orchestration. Now, the key focus of this talk is going to be orchestration. The reason why that's going to be the key focus is simply because orchestration is one of those things that different people see very differently. A lot of people have this one single view of orchestration that says, hey, I need to run everything in my pipeline. I need to have Jenkins. I need to have this specific type of approach to doing DevSecOps, or this is the only approach to doing DevSecOps. And I tend to disagree with absolutist statements like that. And we look at these issues. So we'll first kind of lay out the challenges a little bit, and then we'll focus in on some of the approaches, and of course, do some demos with these approaches. And all of these demos have been incorporated in some way, shape, or form into one of our trainings. So if you take our trainings, you'll get to see all of this in a much more intense light. So you'll talk about this in a big way. All right, so let's start with security tools, right? I am sure if any one of you have been dealing with security tools as part of your job, you will find a few issues with security tools, especially when it comes to automation. I'm not just talking about one category of tools. I'm not just talking about DAST tools or SAS tools. I'm talking about the general category of the larger, broader category of security tools. I'm talking about tools that could do DAST, could do SAS, could do IAST, could do what have you. There are some specific problems when it comes to automation. So let's look at what these problems are. The first one is that a lot of these tools don't really play well with others, right? How many of you feel this way? Show of hands. I think you do have a raise hands thing. So show of hands, how many of you feel this way about security tools? That they tend to be a little narcissistic, right? So security tools, in my view, tend to be a little narcissistic. They don't, they want you to stay within their walled garden. Yeah, thanks for the folks who are raising their hands, great. So they tend to be as part of a walled garden of sorts, right? They want you, hey, look, you don't need any other security tool. You have me to do everything for you. You don't need anything else. This is the best way to do it. Nothing more, nothing less, right? So a lot of them have this very singular perspective of what is good and what is not so good, right? And that also translates to their dashboards, right? So when you have security tools, they expect you to see their results from their dashboard in a way that they want to present it to you. They have very unfriendly APIs or inconsistent APIs. So this is something that I've come across a lot. My team and I, one of the things we do is we set up DevSecOps pipelines for a lot of our clients. And we see this a lot because a lot of our clients already have certain security tools, and they want to be able to make them work in tandem or make them work in a more efficient, effective way. And that's when you need APIs. It's all about the APIs. You obviously don't have a human being sitting in front of the screen managing or orchestrating part of that, of that tool. So you want to be able to leverage their APIs. And if you see some of their APIs, they're really, really terrible, right? I'm sure you will agree with me to a certain extent when I say that a lot of these tools have very, very bad APIs. And of course, one of the other things that we see, and I'm sure some of you have seen this as well, is that security tools tend to be a little long running as part of a DevOps pipeline than other tests like unit tests or even end-to-end tests or integration tests and so on. Now, this is not necessarily an issue with security tools. It's more an issue with a misinterpreted view of what a security tool should do. So that's something that we'll look at a little bit later as well. So in essence, what I'm trying to say is that security tools tend to have a very narcissistic view of the world. They tend to be all about themselves, very self-indulgent, self-important with how they perceive things. So they want you to see their own dashboard. They provide a lot of times not great REST API. They spit out these CSV reports or HTML reports or some other format that is much more difficult to actually parse and manage. And of course, instead of providing useful integrations and playing well with others, they essentially veer towards the side of, hey, let's make sure that this user only works with our tool and nothing else. In fact, one of the reasons why we created Orchestron was essentially for this, right? Because we wanted people to have democratization and be able to manage their tools in a much better way, for them to actually leverage them to do much better things. So that's something that we did when we actually created Orchestron. So that's something that we wanted to really solve, and we have to a large extent, especially with the way we handle certain things. Of course, long-running jobs. There is this idea of the mythical pipeline, right? Now, there is this perspective that, hey, you know what? What I want to happen is that my developer should commit code. That code should immediately kick off a Jenkins job or another CI job. And then that CI job should kick off unit tests, it should kick off integration tests, it should kick off SAST, it should kick off source composition analysis, it should kick off dynamic analysis, it should kick off all of this as part of the same build pipeline. How many of you have seen this, or how many of you have heard of this statement? Show of hands. Everybody's heard of this statement. A lot of you have, especially the prevailing thought leadership around DevSecOps tends to use this as a way to do it, right? They talk about this and say how they've done it, and not more than how they've done it, they say that this is the way to do it, right? You need to have everything in the build pipeline. Now, to be honest, how many of you have actually seen this mythical pipeline in a real world scenario? How many of you have seen it? Very few, if not any, right? I don't see any raised hands. So there's a good chance that none of you have seen this pipeline the way that you've imagined, or way that these so-called thought leaders have imagined for you. Then there's a reason for that, right? There's a reason for that. This pipeline does not exist. Security jobs and functional tests, unit tests are inherently very different in their nature. Now, a DevOps build pipeline typically takes about 1.5 minutes to run, right? And that's a long job. Sometimes it takes even less than that, but very typically it takes anywhere between 1 minute and 3 minutes, a maximum 5 minutes, nothing typically more than 5. 5 minutes is really pushing a build pipeline. So imagine what happens when you push that SaaS tool that otherwise takes about an hour into your build pipeline. Or imagine what happens if you take that DAST tool that scans your application for about 3 hours into your build pipeline. You think that the developers can actually build anything? There's a good chance that they can't, and they just will not be able to do anything at that point, simply because your build is being blocked. Security has become a bottleneck for your DevOps process. And a lot of times there is no need for that to happen. There is just this mindset that is coming to people that they say that, hey, I need this to happen, so it has to happen, without understanding the ground realities and what's actually required for people, right? So what is required for the organization? So I generally don't like this mythical view of DevSecOps. I prefer something a little different. I prefer loops, right? I prefer loops. I prefer feedback loops. And let me talk a little bit about feedback loops, right? Now, a feedback loop is essentially when you have somebody doing something and then they immediately or almost very quickly get feedback for what they've done. Now, imagine a developer checks in code or commits code to the repository, right? And then immediately the developer gets some kind of feedback for the code saying that, hey, these lines that you've written are vulnerable. This library that you've used is vulnerable. And as a result, you should consider fixing it before you merge this into the main branch of the repository. Now that is good because the developer is able to immediately fix things without breaking the build. Remember, we're not putting it into this mythical build pipeline, where essentially what we're doing is we're focusing on the build and making sure that we're focusing on the developer's process and giving that developer immediate feedback. She's immediately given feedback so that she can take action and then start to fix things as part of that process. So feedback loops are very important. If you get them quicker, it's better. The quicker you get them, you're actually shifting left. Now, a lot of people think of putting tools into a build pipeline as shifting left. That's not the case. Moving your security processes early and often in the pipeline or in the pipeline of sorts is essentially what you want to be doing in order to increase your DevSecOps effectiveness, right? So feedback loops, very important. You want to be able to collaborate, right? Developers engineering teams speak a slightly different language. You want to be able to collaborate and be able to give them feedback without it being a breaking or a bottleneck for them, right? And even better, if you could push that into Jira or something that they understand, tickets, right? Developers speak the language of tickets. If you throw out a Jira ticket and goes into their process and it's assigned to one of them, it becomes a very valid and very, very useful feedback for the developer for them to immediately take action against that particular flaw. Whereas if you hand them a PDF report, we all know what happens to that PDF report. It becomes completely ignored, right? So this is really what we want to do. We want to fix things early and often. We want to identify things early and often. We want to fix things early and often. And of course, we want to speak the developer's language. That's really what we want to do, right? So let's look at CI tools. Now, so far, we kind of trashed security tools. We looked at some of the issues with security tools. Now, let's look at a slightly different perspective and look at CI tools. Right now, CI tools are not all that great either. They have their own set of issues, not all, especially with some of the more mythical tools that we see, right? Jenkins, Bamboo, some of the more old school tools of CI, we've seen some issues with. And let's look at some of these issues, especially when we get into understanding different CI tools, especially the security issues. First of all, you'll probably agree with me on this, right? Jenkins is the WordPress of security. Now, Jenkins is one of those platforms that is extensively utilized for CI. And Jenkins is also one of those platforms that is extensively vulnerable to several security issues, simply because Jenkins is a remote code execution platform. It executes code. That's what it does day in and day out. Jenkins execute code. So for me, it's really weird when somebody says they found an RCE in an RCE platform. So Jenkins or Bamboo or any of these CI tools, a lot of times I have a ton of security issues, and that itself becomes a security bottleneck, right? But on top of that, when it comes to a little more user friendliness, they're not really very CD friendly, right? So in DevSecOps, you're typically hearing two terms, right? CI and CD. CI, continuous integration, CD, continuous deployment, right? And all of this results in continuous delivery, right? So CI and CD, when you have continuous deployment, especially when you have cloud deployments, Kubernetes deployments, serverless, any of these stacks being deployed, Jenkins is not really as friendly as you would like it to be, right? So it's not very cloud friendly. It's not very CD friendly. It's not very microservices friendly. Trying to do a massive amount of microservices is going to be really difficult in a platform like Jenkins. So let's say you have a complex set of microservices that you need to orchestrate and test. Jenkins is going to not be as useful for you. You will see that it quickly starts running into these limitations. So as a result, what we're seeing today, especially because a lot of organizations use these kind of CI models. I'm not saying CI tools per se. Jenkins is just a personification of that entire category of tools. But what we are seeing today is that DevSecOps has become another silo, right? So far, we wanted to avoid this, right? We desperately wanted to avoid this. We desperately wanted to have a scenario where, hey, DevOps is all about collaboration. We want to be able to collaborate as Dev and Ops. But we have started to create this as another silo. So your DevOps team has started to kind of divide themselves into another silo that says, hey, you know what? Nobody touches my Jenkins install. Nobody touches my CI server or CI service, because if they do, then the sanctity of that CI service is then lost. So we see that this has become another silo, which is also causing a lot of bottlenecks in a lot of companies. We see this every single time. A lot of times we've gone into client engagements where we've seen that they have been, they treat it like some kind of a holy cow, where they do not allow anybody to, yes, I understand that you need to have good security, but they really do not allow too much malleability with their DevOps. And one of the challenges with not having good malleability is that you're going to run into iteration issues, you're going to run into scale issues, you're going to run into a lot of issues. So let's look at some more practical. Now, one of the things I want to caveat before I even get started is that none of these are the only way or the best way to do things. You need to figure out what is a good way for your team, your organization, your particular case, right? So don't think of these as best practices. You can think of them as alternative, maybe good practices, depending on the way you see it. So I'm not going to be absolutist and say this is the only way to do things. These are some ways in which we are seeing some of the successes that we are seeing with DevSecOps. So let's get started with better alternatives. So first of all, I really like event-driven workflows. Now, how many of you work with serverless or other event-driven workflows? A show of hands. So if you do work with these workflows, you'll realize what I'm talking about. So event-driven flows rather than workflow-driven systems. So when you're looking at Jenkins and all of these different tools, or typical CI tools, you're looking at workflow-driven systems. Now, workflow-driven systems are kind of set in stone, right? The sequence is already defined. The template is already defined. It is all of the steps that goes into that workflow is already defined. which is fine. I'm not saying that's bad, but I'm also saying that today, with a lot of fast deploys that are happening, with a lot of rapid scale that's happening, you want to be a little bit more flexible. You want to be a little bit more iterative. So you want maybe some event-driven flows. And event-driven flows for us has worked phenomenally well. For a lot of our clients who are born in the cloud kind of clients, it's worked phenomenally well. So we've seen a massive shift from trying to orchestrate tools in an event-driven way rather than a workflow-driven way. Now, this is just an alternative. The other thing that I always like, especially with DevSecOps, or I'd like to see more with DevSecOps, is that I don't see why you need to have this one Jenkins server sitting and orchestrating everything, right? There's really no need for it. You don't need persistent computing systems. The reason why you don't need persistent computing systems is that these are all event-driven flows. You just need that one event to trigger and then to die down. Now, because you don't have persistent computing scenarios, you also don't have security flaws. You also don't have maintainability issues, right? You can change it out. So let's say you're running all of this in a container or a set of ephemeral containers, becomes so much easy for you to actually manage the your continuous delivery and DevSecOps in itself. And of course, if you're on the cloud, then it really makes a lot of sense for you to leverage the cloud features to be able to actually do your CI, your DevSecOps, and generally your DevOps in itself, because it gives you a lot of security services like secrets management. It gives you IAM implementation. It gives you a lot of services that can help you scale your process a lot more, and it can be decentralized in a very powerful way, of course. And these are, remember, closer to developer workflows. Now, developers understand these technologies. So when you do your entire security workflow as part of these technologies, developers get it. And when developers and DevOps and your engineering teams get it, you are likely to see much more success with this type of DevSecOps implementation. So there are some existing options, and of course, I'm going to explore both existing options and slightly more unconventional options. Now, one of the things that I've seen is both GitHub and GitLab. These are the two, probably the largest, some of the largest maybe, repository sources in the world have now come up with their own CI/CD. GitHub has GitHub Actions, and of course, GitLab has their own CI/CD, and they're constantly investing in security. So it's really nice to see that they've brought out a lot of amazing features. I'll be showcasing a GitHub Actions-based workflow a little bit later. And like I already said, event-driven versus workflow-driven. One of the things that I like about event-driven flows is that they are essentially meant to be purpose-driven things. They're not driven by this strict workflow of sorts, right? The problem with workflows is that if there is an exception to that workflow, you need to map out all possible exceptions, and that becomes a maintainability issue. If you have a large, let's say you have a large Jenkins pipeline job, you'll realize what I'm talking about. It becomes really, really complex to manage over time. The other workflows that I'm going to be talking about, the other approaches that I'm going to be talking about are test automation. So we'll be looking at some test automation frameworks like Robot Framework and Gauge that make it easier for you to run your security tooling as part of these workflows. Of course, I'll be looking at AWS step functions to do this example of feedback loops a little bit later. And I'll also talk a little bit about orchestration as we close. Now, the first one that I want to talk about is test automation. Now, this is truly an underrated approach to actually handling security-based tasks, right? Now, test automation is something that a lot of you probably have seen as part of your QA teams, right? The QA teams constantly use some test automation framework to be able to run their unit tests, to run their end-to-end tests, to run their, to run their integration tests, and so on. Now, these frameworks that they use can be leveraged quite a bit to perform security testing as well. And when you do that, one of the things you can do is you can integrate that as part of a single set of workflows, right? So when you're running these tests, you can also potentially run other tests along with it. And that makes it really, really powerful stuff. So that becomes much more of a value add rather than just running security tools with their complicated API. One of the frameworks that I'm going to be talking about two frameworks today. I'm going to be looking at both these frameworks. Now, one is Robot Framework and one is Gauge. Now, both these frameworks, in my opinion, are very well suited to run security workflows simply because they are low maintenance, right? You don't need to understand complex code in order to write test automation in these two frameworks. And I find them much easier to use than a lot of typical test automation frameworks that rely extensively on your knowledge of coding and your knowledge of test automation in the first place. So let's look at some of these examples. The first one I'm going to be looking at is Gauge. Let me just quickly show you that. So Gauge is a pretty interesting test automation framework. And the way it works is that you essentially have a, so this is our lab environment that you are actually, so when we do training, this is the lab environment that all of you typically get when we do training. So let me just run Gauge and explain Gauge a little bit to all of you. So I'm going to run my vulnerable app just to get started. So I'm going to run the Docker container with my vulnerable app. And then I'm going to actually show you how Gauge works. Right now, Gauge essentially allows you to spec out everything as a markdown file, right? So it has something called a spec file, and this is essentially like markdown, right? So if you look at Gauge, you'll see that it looks exactly like markdown, and each header, header 2 is a test case. So in this case, what we're doing is we're saying, so our example, our test suite is called run zap from a markdown specification. And then we're going to run Bandit, which is a static analysis tool. We're going to run Safety, which is a source composition analysis tool. And then we're going to run Zap, right? Now, the cool thing about Zap is we're actually going to run Zap as a authenticated user of our application. So you'll see that all of this is done, and it looks like natural language syntax, right? So Gauge does not, scare you. When you look at this, you don't see very, very complex code. It essentially is implemented by a library in the back end, which allows you to call these test cases, and it implements these test cases, making it much easier for you to compose repeatable tests that can do complete security orchestration. So let's actually look at this in action, right? So I'm just going to be running this spec file, and that's really it. That's what's going to happen, right? So I'm going to do cd root Gauge, and then I'm going to just do Gauge run. Now, the cool thing about Gauge or any of these test automation frameworks is that they make it easy for you to run things, and they give you reporting kind of out of the box. You don't need to sit and, so for instance, it gives you things like screenshots, the HTML reports, it gives you a lot of, and it also gives you a pass-fail kind of scenario right then and there as you're running it. So what we've done, you see, we've run the static analysis scan, we've run the source composition analysis scan, we're running Zap, we're spidering the target, and once we spider the target, we're running an active scan. We have already authenticated. Remember, this is a JWT that we got after authentication. We are scanning the target, and the scan, you can see that it's running at about 43%, but once it's actually done, you will see that it produces a report, shuts down. So you can see that within this simple spec file, we have been able to run an entire security pipeline, right? So all you have to do is literally put this in any CI environment or a GitHub Actions or what have you, and you are done, right? That's really it. And that's one of the extremely powerful things about using this test case. So if you look at the reports, we actually have a bunch of reports that have been generated. The Gauge itself has a very basic sort of HTML report that it generates. Let me see a preview of this. So you will see that Gauge has this. So it gives you a list of test cases that were run, and it gives you details about those test cases. So you see that all of these test cases were run, a Zap report, and of course, it generated this report in a particular path and stored it, right? So that's basically how it did it. So one of the cool things about using test automation frameworks is that they make the entire process, because that's what they're meant for. They're meant to run different types of tests and different types of assertions. So that's a really powerful stuff, right? So that's really cool thing that you can do with test automation framework, especially low code test automation frameworks like Gauge and or Robot Framework. Another demo that I have coming up is the robot framework demo that I have. I'm going to showcase this to all of you. So let me explain what this is, right? So here we're using robot framework to push results into our vulnerability correlation system, that is Orchestron, right? So first of all, what we're doing is we're running very similar to what we saw. Robot framework is also very similar to Gauge, in which that you can see that most of the tests are written in natural language syntax. You don't need to complicate it with a lot of different code or something like that. All of this is implemented under the hood with libraries that we already have. In fact, you can go to our GitHub link and you will find a bunch of robot framework libraries that you can just use and start leveraging in your security automation efforts. It's really cool stuff. In fact, people who have done our training have been immediately been able to go back to their workplace and start implementing robot framework, and they've found some really awesome results with this. So let's look at what this is doing. So it's going to create a directory called code. It's going to clone a repository into that directory. Then it's going to create a results directory. All of this is being done on my local machine. And then it's going to run a static analysis tool against the source code. It's going to run a source composition analysis tool against the source code. It's going to log into the application. It's going to, it's just going to run the authorization token. So this is Orchestron. So what's happening then is after running a SAST and source composition, we want to manage the results effectively, right? So it's going to push it into Orchestron, and then Orchestron is going to get all these results. So right now, Orchestron looks like this. So Orchestron has one application. So you see that Orchestron currently only has one application. So let's look at what this is doing. So this is going to log into Orchestron, and it's going to essentially, create an application, new application object in Orchestron, and then push all the results through Orchestron's webhook, and Orchestron automatically starts correlating all of these results from that point on. So that's one of the cool things about using robot framework with Orchestron. So let's actually run this. Is everyone able to see my terminal? I hope everyone is able to see my terminal. Yeah. Okay, I guess that's a yes. Yeah, cool. So let me run this. So I'm going to say robot archi node robot dot archi underscore node robot. So what it's going to do, it's going to clone the source from GitHub. It's going to create a results directory, Node.js scan, npm audit. It's going to create the results in Orchestron. That's it. Your entire pipeline is done. And now, if you go back to Orchestron, you will see another application created entirely through the API, and it has all the results from our scan. It actually pushed. So we ran two tools. One is the Node.js scan and one is npm audit, and we find that it's actually correlated all the results. In fact, if we look into the first one, which is insecure deserialization, you will actually see that it has been identified in two tools. So the static analysis tool has also identified it, and the source composition analysis tool has identified the same flaw. So Orchestron is essentially smooshed, correlated that vulnerability and said, hey, this is, you have one vulnerability here, but it's been identified in two different ways. So you should definitely look at fixing this. So it also has other additional details like related vulnerabilities, info about the vulnerability itself, the affected instances, the line number. You can actually get the source code. You will get all of that right off the bat because you're able to actually manage all of this stuff as part of Orchestra. So what we did very quickly, we were able to actually create two minimal pipelines, and not just minimal. These are actually better than a lot of real world pipelines that you see that don't have these kind of capabilities built in. We're able to actually leverage these pipelines and push results into a vulnerability correlation and management tool. So that's really interesting stuff that you can do with these kind of pipelines, especially with test automation frameworks like Robot Framework and Gauge. The other one that I want to talk about is GitHub Actions. Now, this has really been impressing me quite a bit, and I'll talk about why that is. Now, GitHub Actions allows you to define your entire workflow that can run in GitHub itself, right? So let's look at that and see how that works. So I'm going to And let's look at the code. So this is an example of a very powerful pipeline, and let's see how this works. So here, I have an app, some app here, which is in the app directory. Now this app is going to be packaged into a Docker container, and then the Docker container is going to spin up, and we're going to test this app for security bugs, and then only then actually proceed it or deploy it in some environment. So this is entirely done with GitHub's new, not new, I think it's been around for a while, but a lot of us have not used it till very recently, is GitHub's answer to a lot of CI tools. So in fact, I think they've done a phenomenal job of a lot of the CI tools that they have. So this, you can define the entire workflow on GitHub with this in a YAML file like so. And one of the cool things about GitHub is that you can leverage a lot of pre-built actions. So let's say somebody else has come up with an action that does something. So in this case, it's going to check out some code. This action is going to set up Python. Now, this is something I don't have to manually do, right? I can just leverage somebody else's action and say that, hey, use this person's action and then run it as part of my CI workflow, right? So that's something. So what we're doing is we're installing Python, then we're running Zap, then we're opening up our container, we're accessing our container on port 5050, running Zap entirely, and then producing a report with Zap's scanning capability. And all of this is done with a end-to-end authenticated scan in Zap. So let's see how this works. So I'm going to make a small change to this file and commit it. So as soon as I commit it to my repository, that's when it kicks off, right? So I'm going to just make a small change, right? Nothing very, very fancy. I'm going to make that small change, and then I'm going to git add, git commit, minor change to actions workflow. And I'm going to git push. Now, as soon as I do that, the action is triggered on my GitHub repo. So let's look at this. Now, you can see that GitHub has started the actions on my repository, and you will see that it's starting to run that workflow. So you'll see that it's checking out the code. Remember, we're doing a full, this is actually compared to a full build pipeline. It's actually a full build pipeline. So look at it. So the code is actually getting built in this part, and it's building the Docker container. Once it builds that Docker container, it's going to run Zap and run Zap against that Docker container, right? The running instance of that application that's running as a Docker container. So you can see that it's downloaded, it's installed, it's actually built the Docker image. Once it builds that Docker image, you will see that it actually is going to run. I think it's going to take a little bit of time to build it. Just give it a few seconds. So it's installing all the dependencies for that application while it's building that container. And we should see that it should get started. The next step should get started pretty soon. Yeah, I think it's almost done. So this is essentially building that image into a container image. And once that is done, it's going to start running. It's going to download Zap, and it's going to start running Zap. So it's going to run the container, run Zap as a process. Now, since Zap is a heavy process, we also have a small 20-second sleep before it actually runs the Zap scan. And once this 20 seconds are done, it's going to run a full-fledged Zap scan, authenticated. Remember, we're not spidering the app in this case. We are running a fully authenticated scan against that application, right? So it's going to run Zap. Now you can see that the Zap scan has started. It's going to authenticate, so it's going to take very little time for the scan to actually complete, and it's going to be done. You see that the scan is done, and it's going to write the reports, and that's it. So you'll see that with GitHub Actions, you can actually get a very powerful orchestration workflow. So imagine GitHub Actions, like the previous time we pushed results into Orchestron, just before it terminates, you can just say push results to Orchestron, and it actually orchestrates that entire process. So one of the cool things about using these kind of workflows is that you are essentially decentralizing a lot of the process. You're not depending on this one CI tool. All right, you're essentially creating multiple feedback loops that becomes much more flexible rather than this one single monoculture type view of the world. Right, that's something that is definitely something that you will see with a lot of these tools. The other thing that I want to talk about, just to close the webinar, is cloud native DevSecOps. Right now, the cloud, especially not just AWS. Of course, AWS has probably been at the forefront, but you can see Azure and GCP as well. They have a lot of the tooling that allows you to do or allows you to write your own orchestration framework of sorts, right? And that's one of the most powerful things that you can do. In fact, one of the things, one of the services of AWS that I really like is the step functions service. Now, a step function allows you to define a state machine. So it allows you to define multiple rules, and you can pass a particular input through multiple states and process something. So you can process input. So people use this to transcode video files. Some people do this to perform some workflow-based process. So for instance, when we sign up people to our application, we essentially trigger a bunch of back-end step functions for people to process payment, and once they've finished processing payment and so on. You can use it for literally anything. So in fact, one of the things you can do is also trigger a lot of security-based tasks on events based on step functions. So you can do shorter-lived functions like AWS Lambda, or you can trigger a larger container-like object like Fargate, and you can actually trigger this and orchestrate your entire scanning process through step functions. Right. One of the cool things about step functions is that you can model very complex workflows. This is very difficult to do with things like Jenkins and so on. This you can model very, very complex flows. So let me give you an example of a complex flow in a little bit. But one of the things you can do is definitely model these complex flows. They're event-driven, which means that if the flow does not need that particular task to run, it just won't run. Right. So it's event-driven. There's no real compute, there's no persistent compute. It's not relying on this one single box to do everything, right? These are just fired based on a sequence of events, and that's it. It's done. You don't really need to run any persistent infrastructure to actually do this. And again, since it's on the cloud and since it's very close to your engineering team, it becomes very easy for you to scale with something like this. So let's look at one such workflow. So in this case, we want to provide the developer with a very, very quick feedback loop, right? Very, very quick feedback loop. So what we want to do is, as soon as the developer creates a pull request, it's going to hit our step function, okay? So it's going to hit our step function. So as soon as the pull request is triggered, GitHub triggers a webhook to our step function. Now, when this happens, we will first check whether any of our Python files have died. So this is a Python application that I'm running against. So the first thing we're going to check is, hey, have any .py files changed in the pull request? So whatever is in the pull request, it will first check whether any of those files are .py files, if they've changed. If they have indeed changed, then it will run a static analysis tool called Bandit, right? So it'll run Bandit and then write the results of Bandit to the pull request. Then the next step will be essentially running the source composition scan. Has any of your third-party dependencies undergone any change in this pull request? So have you added any libraries? Have you removed any libraries? What has happened? And has that triggered any change? If there are changes to your requirements.txt file, which is the inventory file in Python, it's going to run another tool and post results to your PR. So you get immediate feedback when you run something like this against your when your developer checks in code. So let's look at how this works, right? So I'm going to run this as a workflow. Oh, sorry about that. I think I got the wrong directory. So that would be, yeah. Right. So in this case, I have a repository with only 2 files. So I'm going to make a change to one file. So I'm going to remove one of the dependencies. So I'm removing this Flask dependency. Then I'm also making a small change to the zap. So this is a Python file. So this is not, I mean, just imagine that it's something else. It's not really doing zap scanning or anything. I'm just saying it's called zap.py. So I'm going to save this file and I'm going to make a small change to zap.py, save this file. And that's really it. So what I'm going to do is I am going to commit this to a test branch. So remember, I'm not committing it to the main branch. I'm going to commit it to another branch, open a pull request, wait for somebody to review my code, and then they will merge it into the main branch. So what is going to happen is that I'm going to say, please merge these into main branch, right? So this is what the developer does, commits to the test branch. And let's look at, so now it's committed to the test branch and it's done. So let's go back to our, so let's say the team lead comes in and so the developer goes into the test branch. Now the developer needs to create a pull request, right? So I'm going to create a pull request. I'm going to close this. This is not required. Sorry about that. GitHub does this. I need to disable this. So let's create a pull request. Okay. So I want to create a new pull request and say, hey, I want to be able to merge these two branches. I'm going to create a pull request. Team lead, please review and sheesh, sorry about the butterfingers, and merge. All right. So I want to create the pull request. Now, let me explain what happens here. Now, when that pull request is triggered, it hits my AWS step function. So the step function essentially works like a state machine-based workflow where it has a visual definition language as well. So it checks for the Python files, and then if there are Python files, it runs the static analysis. If there are no Python files, it directly jumps to the requirements.txt. If there are nothing there, then it writes to PR, and that's really it, right? So it runs this entire workflow. So let's create the pull request. And now let's look at our step function getting executed. It should be running now. So it sees that, yeah, you see that it's done with the whole thing and it's writing. And at the same time, you see that the results have already started going into my pull request. So this has started writing results back into my pull request. So it says that, hey, Bandit has these issues. The libraries that you're using have all of these different security issues. So clearly, it's not a good idea for you to merge. So you see that this is an example of a very, very simple yet extremely powerful feedback loop, right? The developer just checks in code. Immediately, the developer gets feedback saying that, hey, these are two issues that we're seeing. Definitely, you need to take cognizance of this and maybe fix all of these issues. And you add them as pull request comments. So somebody seeing this pull request clearly sees that, hey, these are issues. Obviously, we can't merge it. You need to fix it before we merge it. So you can say reject it, or you can give some feedback to that particular user and say, no, I'm sorry, please fix all of this. It's already given here. Please fix all of this. And all of this is done with no persistent resources. You can see that all of this is done in a matter of a few seconds, because remember, we're not doing an entire static analysis scan. We're just scanning only the part of the pull request that is specific to that particular pull request. We're not scanning the entire code base. We're scanning only a few files or a bunch of files in that particular pull request. So we're able to orchestrate this quite powerfully as part of our entire workflow. So these are some of the things that are making a big difference in having your DevSecOps workflows become much more efficient and much more effective as we go on. Right? So I think I'm almost out of time. So let me just explain another example. So we were we were working with a customer to do a bunch of step functions for not only this kind of a workflow, to also run check marks and run Zap, and of course, write all of that back into Orchestron for further analysis. And we were able to achieve this entirely with a AWS step function, right? So that's something that you can see. So all of these things, you can see that all of these processes can run as a and you can parallelize a lot of this as well. It doesn't have to be sequential. So you can say that DAST can run as one branch, SAST can run as another branch. Obviously, they're not connected. They can run parallelly. You don't have to wait for one to finish before the other starts. So you have all of those possibilities with step functions. In Azure, they're called logic machines, I think. I think they're called logic machines or something like that. Logic applications or something like that. I'm not sure. Something logic and something else. I'm not exactly sure what they're called in Azure, but they're equivalent to the functionality provided by the AWS step function service. And of course, one of the things you must keep in mind, especially when you are getting into orchestration of any sort, is that, hey, you're producing all these results from a lot of tools, but what do you do when you actually have to manage these results? And that's where it becomes challenging, right? So you need vulnerability management or correlation of some sort. You definitely need to have some kind of a correlation strategy. You can use Orchestron, of course, any other tool that's out there. You can, let's say you want something a little bit more basic. You don't want, let's say you don't want all that complex, a lot of functionality. You don't have the time to invest in something like that. Then you may want to look at something like Athena from Amazon, which allows you to query stuff from S3 buckets. It is definitely a lot more hard work than using a vulnerability correlation tool. But let's say you already have expertise in that space. That's something you can do. Also, you can have more asynchronous kind of consumption possibilities, right? So Slack, Jira, etc. So one of the things you can do with Orchestron is also do this, that you can also push it to Jira and have a two-way sync between Orchestron and Jira and so on. So those strategies also need to be explored once you're doing. So orchestration is one thing, but once you do orchestration, you should definitely look at how you can leverage that in the form of reporting and management of those vulnerabilities, and not just running tools and getting a bunch of results that leaves you overwhelmed, right? So that's something that you should keep in mind. So a few conclusions before we close. Think feedback. Don't necessarily force fit security into pipelines. Think beyond CI tools. Now you have a lot of options today. You don't only have very specific CI tools. You have test automation frameworks. You have the cloud. You have, of course, the source repositories themselves that provide a lot of these functionalities. This is really great. And of course, if you're doing cloud native stuff, container native stuff, there are things that are meant for those services, like Argo CD or step functions, or your cloud orchestration system itself, or something with your infrastructure service provider like Terraform, something like that. That's also something that you can do. Of course, finally, when you're doing all this orchestration, you need to have a vulnerability management and correlation strategy, because you have so many vulnerabilities coming at you from different places. You need to be able to manage it in an effective and sane way. So this is something that I want to say before I close. Thank you very much for attending. I'll be happy to take any questions at this point. Do we have any questions? One second, please.
There were a couple of questions that were largely just about the presentations and things like that. I don't see any questions. If you have any questions, please do. We're going to wait for a minute or so for any clarifications, feedback, questions. Okay. Doesn't look like we have any questions. So with that, thank you very much, everyone, for joining this webinar. And like I said, we do this every month, so feel free to kind of check back with us, or if you're following us on Twitter or LinkedIn, you will have notifications. Once again, a reminder for those who are interested in our training programs, the link is in the chat window. Please feel free to go ahead and look them up. 1 second.
Sorry, we do have one question.
Yeah, we are. Do you see the question?
Yeah, so I do see the question. Thanks. Let me get to it. Yeah. So we are planning. So the question is, we are planning to set up DevOps in our organization. As per your presentation, we plan to go for GitHub Actions. Yeah, GitHub Actions is a pretty powerful tool. Definitely, you can leverage GitHub Actions for anything related to DevOps, because you do have that capability. You just need to make sure that it suits that particular product, suits that particular product's pipeline, and so on. So yeah, you can definitely use it. Yeah, you can. Of course, Jenkins and Circle CI are also tools that can help you do a lot of what GitHub can. If you are already on GitHub, that probably makes a lot of sense to just use that. But if you want to use something a little different, then maybe Jenkins or Circle CI is fine too. Just give me a second, Rahul. Yeah.
Any other questions before we close for the session? All right. So if you do have questions, feel free to kind of ping us on our social channels or on the YouTube live stream. We'll be happy to kind of take them as well. So thank you everyone for joining in, and look forward to kind of seeing you once again. Have a good day and stay safe. Thank you.
Thank you. Thanks a lot.